Alright, hello everybody. So today I'm going to be doing a tutorial on partial derivatives. This is a topic in multivariable calculus. I'll be putting it under the playlist Calculus Beyond AP. So here we have a function f of xy is equal to 2x plus 3y plus 5xy. So if we have this, we are going to want to take the partial derivative for this problem. So how does that work, you might ask? So first of all, you need to decide with which variable, and you can choose either x or y in this case. Let's say if it was x, y, z, you could also choose it with respect to z as well. But for now, we're going to do it with respect to x. And when you do that, you put a little subscript here, and you don't need to fill in the x, y, and all that. So this is the method of writing it, the notation. So f subscript x, and then we're going to take the derivative with respect to x of this function right here. So how's that going to work? Basically what happens is you treat y as if it is a constant. So you'll notice that there's x's and y's in the function. We're going to treat those y's as constants. So we're going to get 2, because the derivative of this is 2. The derivative of this is going to be 0. The derivative of this, this is a bit more complicated. We're going to have 5 times y. Remember, y is a constant, or that's what we're imagining in this scenario. So that means 5y, and then you have x, so it's just going to be 5y. So that is going to be the partial derivative with respect to x for f of x. Now, you can also do it with respect to y, so we're going to do 2x plus 3y plus 5xy, and we're going to do it the same way. So this is going to be a constant, 2x, because we're taking it with respect to y this time. X is going to be a constant in this scenario, so we're going to have 0 plus 3y, the derivative of that is going to be 3. And then the next one we have 5xy, and then we can take the derivative with respect to y, and that is going to be 5x. And you can simplify that, obviously. You can take out the 0 and do other work with it as necessary. So that's the first partial derivative. And there is a concept of the second partial derivative. Now that gets a bit more complicated because you can have multiple. Before, if you guys remember, if you had, let's say, a function f of x, you would have maybe a function f prime of x, and you would get f double prime of x. That is going to be different in this scenario. We are going to get much more second derivatives than you might expect. There are going to be multiple second derivatives. You can do f of x, x. What this is you take the partial derivative with respect to x, and then you do it again with respect to x. And then we can also do partial derivative with respect to y and y. So you take the partial derivative with respect to y, as we did here, and then you take the partial derivative with respect to y again of this function. You can also do f of x, y, and f of y, x. And it just so happens that these two are equal. So if you do xy or yx, in the order actually does not matter. There's a certain theorem for this. I don't remember the theorem's name off the top of my head, but there is a theorem that states that f of xy, f, the partial derivative of x, and then to y, is the same as with respect to y with respect to x after. So the order here doesn't matter, but these two are not equal. These two are not equal. So if you do xx, you do yy, they will not necessarily be equal. But if you actually test it out here, they will end up being equal. But this is just one scenario. It will probably be different for most scenarios that you encounter. So let's try solving for some of these. Let's start with f of xx. So we got f of xx right here. We're going to solve for it. So we got 2. So basically what happens is we take our original one, we take the partial derivative, which we've already done right here, and then we take the partial derivative of this. What we're going to get is 0, because we have a constant 2, and then 0 again. And 5y. That's going to be 0 as well. So that's just 0. F of y, let's try that. F of y is going to be, so we're going to take the derivative, 0, partial derivative, sorry, 3, that's also going to be 0. F of x, that is also going to be 0. Remember, f of x is a constant here because x, since we're doing it with respect to y, x is going to be a constant. The next one we're going to take is with xy and xy, so we're going to take this with respect to y. So you're going to get 2 plus 0 plus 5, and then we're going to take the partial derivative with respect to y, keep in mind. So with respect to y, these two are both constant, so that's going to be just 0 plus 0. And then 5y, that's actually going to be 5. So f of xy is going to be 5. Now we're going to try f of yx. And we're going to try to see if this holds true, if they're going to be the same. And some of you who might have solved it a bit quicker, you might have noticed that they actually are, but I'm just going to go do it right now. So f of y we have here, and we're going to do it with respect to x. So we have 0, 0, plus 3, that's a constant, so that's going to be 0 again. Then we have 5x, and that's going to be 5. And we're going to see that this is equal to 5. This is also equal to 5. 5 equals 5. F of xy is equal to f of yx. And that holds true. Now, I mentioned earlier that these two are not necessarily equal, yet they ended up being equal in this scenario. This is just because I chose a pretty simple function. I probably should have chosen a better example for this, maybe one involving maybe something with an exponent, f of x squared, like, sorry, not f of x squared, but like x squared or a y squared term. I think that might have been a better example. That's my fault. I'm sure you can find better examples than the one that I chose here, but this is pretty simple, and your math teacher may or may not include that. This was just designed to give you an intro to partial derivatives and second partial derivatives. I hope you guys did find this helpful. If you did, please be sure to leave a like on the video and subscribe. Leave a comment for any future videos you'd like to see. This is something that I really like doing, so be sure, if you guys do want to see videos like this, be sure to hit that subscribe button and leave a comment. So, thanks.